Hi everyone, thank you all for being here. I'm very glad to have this opportunity to speak at this conference. Today I would like to present our paper, Communication Efficient Decentralized Learning with Sparsification and Adaptive Peer Selection. I'm going to begin with the background of distributed deep learning and then discuss the issues that affect throughput distributed training. Then I will introduce our algorithm and show you our experiment results. In the last section, I will talk about some of our future directions. So as you know, the deep neural networks have been widely used in many areas like computer vision, natural language process, knowledge graph, etc. The process of training deep neural network is like this figure shows. We input the data into the deep neural networks, and the data are transmitted layer by layer through the model until it reaches the output. In the background propagation, the loss and the gradient will be calculated out and transmitted backward to the first layer. Now, the gradient of the whole model is obtained. Then the optimization method SGD uses this gradient to update the model parameters. Then many people may care about how to speed up the training speed. This question is very important. A company used method is to add more computing devices into it. But how to distribute the multiple training devices appropriately is not easy. One data parallel distributed SGD is like this figure shows. There are 4 workers, and the data is split into 4 parts. Each worker owns one part of the data and performs the feed-forward and back-propagation process by itself. After attaining the gradients, they need to do gradient average between themselves. Then use the global gradient to do the SGD by itself. You can see the object function of distributed SGD is different from the single device version. And the object function has an average operation. The problem of distributed SGD is that the communication data is too large. And in recent years, the deep neural network models are becoming larger and larger, like VGG16, which has several hundreds of million bytes. If network bandwidth is low, the communication time will be very large. And another problem of distributed SGD in centralized architecture is the high network congestion. In this figure, we can see that there are many workers connected to the servers. This architecture is called parameter server, in which all the workers will send and receive the gradient from and to servers. So when all workers send and receive data from the servers, the network congestion will happen on the servers. Then how can we reduce these communication problems? One algorithm is federated average, which is an algorithm firstly used in federated learning. This is very similar with local SGD. During this training process, it will not communicate with server every iteration, but do local updates for several rounds. Then it transmits the newest model to servers. The advantage of this method is that it reduces the communication frequency. So the total communication size is reduced, but the communication data in one communication is still large. The network congestion is still high. So let's see another algorithm, decentralized SGD. This algorithm is proposed by Shangru Lian in 2017. And this algorithm makes each work only communicate with several peers. The communication topology is sparse. Let's see this algorithm in detail. In each epoch, the worker will compute the gradient itself, but not do the update, and communicate its model with its peers, then do average with these models of its peers and its own. Let's see it in the pseudocode. And at last, the workers will do the SGD with the newest averaged model. So the decentralized SGD alleviates the network congestion, but the communication data is still large. So there is another approach to improve the DPSGD. It is called DCD-PSGD. This method will save the models of its